So now on to the interesting thing. The mitochondria, we mentioned them earlier. They are the powerhouse of the cell, and really started as, early cells were what were called prokaryotic cells, which used fermentation to create energy. Sort of like the fermentation that you see yeast doing, and fermentation that, say, when you make sauerkraut.
Okay.
You get lactobacillus, it creates lactic acid, and for each sugar molecule, these more primitive organisms can produce 3 ATP, the chemical energy. Now, the mitochondria was this little organism that got into our cell, infected an early, prokaryotic cell, and but it developed a relationship with the cell. The cell gave it nutrients, and the mitochondria, the little bacteria, would create this chemical energy because they had this machinery called, oxidative phosphorylation, OXPHOS, which is basically can take one molecule of glucose and make more than 30 ATP molecules.
Wow.
So it's 10 times as efficient as fermentation. And so that is what allowed the multicellular organisms to be able to come together, and really allowed the brains to be developed, because our brain takes 30% of our caloric intake. It's 30% of our energy goes to running this thing in our skull.
Wow.
Which is, and you think of everything else your body's doing,
Yeah.
the brain is just using huge amounts of energy. And that as humankind evolved from early forms, from to later forms, the ability for us to eat more efficiently, and particularly to begin to develop tools to where we could kill animals,
Right.
and then to discover fire where we could cook, because cooking actually allows better absorption of the nutrients of, say, meat,
Yes.
meat, the animal products.
Yes.
Not so much the vegetables, but a little bit perhaps. And so it's actually really interesting. So what we want to do is to keep our cells healthy. The other thing the mitochondria does is, being the central processing unit of the cell, it controls a lot of the processes, particularly the programmed cell death. That if it sees that a cell is struggling, it'll trigger the mitochondria. The mitochondria will basically trigger these portholes in the cell, that all the important stuff will leak out, and the cell will just sort of implode.
Oh.
Which is good, because if you have a sick cell, and
okay.
and it can do that to cancer cells.
Oh.
And so that's why you want to keep your mitochondria healthy, because they will control your cancers. Now, the signals that turn on your mitochondria is reduced food supply. So if the mitochondria sense that there isn't enough nutrients coming in, it triggers them to think, okay, I've got to make the body as efficient as possible. And so what happens is it basically sends the message to the nucleus. Number one, need more mitochondria,
right,
because that makes everything. And then to recycle all the waste. I mean, all of these reparative mechanisms go into process when there's inadequate calories. And we always thought that, well, I need enough calories to run my body.
Right.
What you want to do is to get your body as efficient as possible, so that it'll run on fewer calories. So it's actually interesting. And then the other thing that turns on our organelles, the mitochondria, is stressful exercise. And unfortunately, we're talking interval exercise. I won't say it's necessarily high intensity interval training, but your mitochondria will sense when you're short of breath and sweating. And so if you're short of breath, that means the mitochondria aren't keeping up.
Oh.
And so, and that what happens is that, the mitochondria go, hey, it's like, we're not keeping up here. So it sends a message through this oxidative stress. This hydrogen peroxide begins to build up, which then is a messenger to the somatic nucleus, to the nucleus of the cell, to tell it to turn on the machinery, which the mitochondria donated, the machinery to make more mitochondria to the cell, because it wanted to keep just the energy component, so it can be the most efficient. And so it turns on and it triggers the whole mechanism of making new mitochondria. And it does that by taking the old, worn out mitochondria and taking their parts and turning into new, young mitochondria. And the difference between old people and young people is the health and the health and strength of their mitochondria.
And you and I are the same age.
Yeah.
And we're really at the age where we want as healthy a mitochondria as we can
We
have.
want to get there.
Yes.
And what's really interesting is, there have been all these antioxidant studies.
Yes.
Can we prolong life and reduce aging by taking vitamin E and vitamin C?
Right.
And the answer is no.
Oh.
All the studies on vitamin E show increased heart disease.
Oh.
So there's really, and it turns out some of this may be explained by if you're exercising or if you're in a fasting state, the messenger is oxidative stress from the mitochondria to the nucleus. And so if you take 1,000 milligrams of vitamin C, you're cutting the phone line from the mitochondria to headquarters.
Oh.
And so you got these guys out in the field,
Yeah.
and it's like, we're getting hammered here, and somebody just cut the phone line. And so the mitochondria get no reinforcements.
Yes.
And you get old. And so don't take C. And actually they did a study taking athletes and having them exercise and seeing what happened to the training effect. And then they basically gave them vitamin C, had them exercise, and showed that they could block the training effect of
Oh my goodness.
interval exercise. So,
which you don't want to do.
So if you're going to take a multivitamin, don't take it before you exercise. A lot of people like to take vitamin C when they're sick. Well, you shouldn't exercise when you're sick, because if you're viremic and you exercise, all that virus goes to your heart. You don't want it going to your heart. So if you're sick, take a break.
Okay.
And
when you say sick, like if you've got
fever.
a light cold, if you got fever.
If you got a fever, do not exercise, because that means your body is trying to heal, and what you need to do is to go crawl in a corner.
Yes.
And call your boss and say,
rest.
I'm crawling in a corner.
Yes.
And rest.
And so you don't transfer it to your coworkers.
And so you don't transfer it to your coworkers. And so it's interesting. So you think that, well, gee whiz, if I exercise, I'll lose weight.
Right.
And if I fast, I'll lose weight. But it turns out your body's becoming much more efficient. And so what they showed, there was a study in the Scientific American about this hunter-gatherer tribe in Africa. And this was just shocking to me. And they could measure calorie consumption with some kind of heavy water thing. And so the tribal members would have to drink these whole bottles of water, and then they would measure the metabolites that were coming out, and somehow they could calculate calories burned, not just by work done, but by what was happening metabolically. And they showed that the team followed this one hunter. They were following numerous of them, but the story was about this one guy who the previous day had hit a giraffe with a poisoned arrow, homemade poison. Yeah. And so what they would do, because these giraffes are huge.
Right.
And clearly, it's like, and with just the tools that they had, this was how they killed the animals. And so, but then what you had to do is the next day you had to go out, track the giraffe to hopefully find the dead giraffe. And so these guys go out and they're just walking all day, tracking this animal. And they showed that he burned the same number of calories as the office worker in the United States, sitting in his desk doing nothing.
Sedentary?
Sedentary, because this guy's body was so efficient that, and really what you think about is the sedentary person, their body is consuming huge calories, just managing the inflammation, creating the inflammation, trying to repair the things that are being damaged. And so there's a huge amount of thing. And so suddenly, if you eliminate all of that inefficiency, you need fewer calories,
right.
Which means you can eat even less, which is really, so then it's kind of tough.